Good evening, Sky people. Welcome to the Astro Imaging channel. My name is Molly, and tonight we have Timothy Martin with us to talk about using Nina for remote automation, including using the Sequencer Powerups tool, among other topics related to that. Kind of continuing on our theme of remotely operating your telescope, whether that's in the backyard or distantly, which I think is a fun topic. But before we get to him, let me just run through our upcoming schedule here. I'm not going to share my screen, but if you go to our website, theastroimagingchannel.org, you can see our calendar and see what's coming up. Next Sunday is Labor Day, so we are not having a show next Sunday, so that we can all go enjoy our holiday weekend. Most of us probably won't be here anyways. Then the following week, I'm actually going to step in and give a presentation on why you should go to star parties and talk about some ones that I've been to, some fun things that have happened at them, what you should expect at a star party, ways to prepare for one, and where you can find one near you. So I'll go through all that star party fun. And then the following week, we have our Jaime, who has recently joined our team. And he's going to talk about using the fast processing tools in PixInsight to kind of plow through, to get quickly through a processing chain to kind of see what you got so far. So yeah, that's our upcoming schedule. So I also today I posted 2 new TAIC shorts. So TAIC shorts are clips out of our hour and a half long videos that are kind of individual topics that are then it's a lot easier to go look at that one topic and to link those topics in forums and Facebook and stuff like that. So I took the 2 out of our 10th anniversary show, one with Alex talking about everything you need to know about dithering. It's very thorough, it's very good talk. And then I had one on how I image with multiple rigs while I sleep, things about hardware and Nina and stuff like that. So both of those are posted. And occasionally when I have a little bit of time and feel like doing that, I'll there's a lot more videos I need to go take clips out of, but we'll get there. I'm getting those posted slowly but surely. Let's see, I think that was it. We've got some holes in our schedule if you are to go look at our calendar, and so I'll make our usual plea for if you have anything that you would like to present, if there's a cool piece of hardware that you use, if there's a processing technique or a group of techniques that you use in PixInsight or Photoshop or Serial or Astro pixel processor. It doesn't have to be PixInsight. There's other software out there that people do use, and it'd be good to see some of those tutorials as well. If you've got, see what other kinds of topics. Yeah, we're always looking for fresh ideas for topics as well that are somehow related to astrophotography. So you can go to our website, theastroimagingchannel.org, and hit the contact us button and shoot us a message, and one of us will get back to you and see if we think that it'll be a good fit for the show and for our format. Yeah, go ahead and reach out. I think with that, go ahead and let me introduce Timothy here real quick. Tim is a retired attorney and former CTO living in North Dallas with his wife, Christi. He has a daughter, Danielle, who lives in Stockholm. That's cool. He's been interested in astronomy all his life, but started doing astrophotography in about 2019. Currently has 3 telescopes operating down at Deep Sky West, which is not far from me, down here in New Mexico. And yeah, so Tim, take it away.
All right, thanks. Yeah, so yeah, I have 2 scopes here at home too. I used to have 7, and I thought I had a problem, but I've got it under control now. I'm down to 5. I can quit anytime.
At what level is the problem? I need to know.
I don't know. I don't know. So, yeah, so I'll go ahead and start the presentation.
All right.
I hope I'm not forgetting anything. Yeah, so thanks for having me. And
looks good.
I hope you guys find this useful. So I'll do the best I can here. Let's see. I'm going to have to stop that.
You're coming across fine. There you go.
Okay. It's not displaying right for me here, so I'll have to restart it. That's okay. Okay. It's all good now. Okay, so she already kind of had my bio. I was a programmer for 30 years, then went to law school, and now I'm just an unfrozen caveman lawyer, and retired in 2021. Been married to Christi for 40 years. My daughter Danielle lives in Stockholm, and so I'm currently a childless cat person. I have two helpers, Saturn, who likes planetary, and we got her from the rescue agency with that name, and then her big brother Seymour. So who is this presentation for? Really, it's for people with rigs at remote observatories who like to use NINA or want to learn more about NINA, and those with home observatories that have safety monitors. So, when conditions are such that you need to stop imaging. The goals for tonight are to just try to help people learn how to manage the nightly imaging process a little more intelligently, to start and stop when appropriate, and handle various roof closure scenarios, and then also provide some meaningful real-time messaging if you want such a thing. I have messages come to my phone constantly during the night, and then also fully automating taking calibration frames. Things we're not going to cover include any kind of long-term automation of your telescopes, periods longer than one night, but long-term scheduling and target selection and things like that. We're not getting into that. I don't know much about that, frankly. I know there's a target scheduler and some other tools in NINA. I haven't looked at them yet. We're not going to cover power management, automation, external scripting, or anything about managing the observatory itself. So we have some kind of basic requirements for what I'm going to be talking about to work for you. You're going to need decent internet access. Of course, that's kind of a given with remote observatories. Some may be better than others. At Deep Sky West, we've got really good internet access. There's a fiber line going out there, and so we have good access. There's no limit on how much data we can download or upload. I've been there a year, and we've only had 4 or 5 outages that I'm aware of, and they didn't last very long. So that's pretty good. You need a working ASCOM safety monitor driver tied to your observatory or dome, and then you need to have NINA with the latest version of the Sequencer Powerups and ground station plugins installed. And then I got some other recommendations here. A lot of them kind of go without saying. A good mount, an automated focuser and rotator, automated cover, and flat panel. The bigger scopes, it's kind of ridiculous to think about putting an automated cover on them, I guess. Probably about as big as you would want to go would be 12-inch scope. I have an automated Primalucha Labs Alto Giotto on my CDK12, and it makes me nervous. I don't know that I'm going to leave it there permanently, but we'll see how it goes. It's always good to have a shutter on your main camera, but a lot of cameras don't come with that. But that makes some of this stuff a little bit easier. And then one thing I've noticed is when I first started this, you didn't really need much of a computer to do this. And I've just seen kind of even just the image capture process starts to chew up more and more computing power, partially because of some of the tools that get added. I know Hocus Focus likes to kick off lots of threads and can be fairly processor intensive for short periods of time. And then the camera sensors are getting bigger and bigger and bigger and consume a lot of processing power just downloading the images and managing the images, stretching the image for you to see, and so on. So the more computing power you can put on your rig, the better. I don't want to spend too much time on this. Also, PhD 2 is good to have if you're trying to guide, or something that will help you guide. And then additional plugins that you might want to consider are the connector plugin, so you can connect automatically to your gear. The PhD Tools plugin is very nice. It can start and stop PhD 2 and puts a little display in Nina for you if you want it. And then Hocus Focus is pretty much a must-have for me. John Hayes has written, and I have his permission to talk about this, has written a really excellent guide to best practices for remote imaging. And there's a link to it here. You can also find it if you go on AstroBin and just go to the forum and search for John Hayes best practices. And one of those messages in there will have a link to this document. But it's a really, really good document. I wish I'd seen it 2 years ago. This is one of my configurations out of Deep Sky West. It's a TAC TOA 130 on a GM 2000 mount. I'm using a Moravian C5 100 camera, and this is what I'm talking about when I'm, needing more computing power. The subs that come from that camera are 200 megabytes, so it adds up pretty quick, and it takes 4 or 5 seconds to download them. I think probably most of that is the camera, not necessarily the computer. And then I have an Alto Giotto flat panel cover on that scope, Nightcrawler, focuser rotator, and an Intel NUC. Those are really the relevant items here. And then, of course, as I've already mentioned, all these components, these software components. This is the software I'm using as well. So kind of before we jump into Sequencer Powerups and what it does, I thought it might be good to just do a basic review of what the advanced sequencer does. And for people who haven't used it and haven't seen it, I thought it might be good to just go through it. Need to go through this fairly quickly, though, in order to have time to get to the things that I really want to discuss. So are there any questions so far? I'm going to take that as a no.
Yeah, you can take it. We don't have any questions yet. It's a little early. Give them a few minutes. They'll have some. Okay,
good deal. Yeah, just chime in anytime. Stop me anytime. Okay, so in the advanced sequencer, it's made up of a bunch of different components, and the basic building block is called an instruction. So you can drag and drop an instruction into your sequence, into your Nina sequence, and it's just an instruction just causes the rig to carry out some task, slewing or opening the cover, dithering, various different things. There's dozens and dozens of them, and they show up in a column on the right. We'll see here in a second, classified by what their either their activity is or what piece of gear they're connected to. So over here on the right, you see these are all the instructions and various other components you have available to you in Nina. And then this is the sequence, the advanced sequencer area. And here we see a couple of instructions in a sequence, just to slew and to take a few exposures. The next component is called a container. You probably don't hear this terminology a lot, but I'm going to be using it quite a bit, so I wanted to define it pretty well here. So a container is an instruction that can contain other instructions. It may be conditional. That means it may only execute the instructions within it based on certain conditions. Some types of containers are just part of the advanced sequencer. The Deep Sky object instruction set, that's kind of the big one. And then there are a couple of different kinds of instruction sets that you can actually put inside that container. So as the slide says, some containers can house other containers, and those 3 containers definitely can do that. Those 3 built-in containers. Sequencer Powerups extends this quite a bit. It adds various kinds of containers. You can have an if test, and you can put an expression in the if test, or an if then else construction, where you put an expression in there and only execute the instructions inside that container if the conditions are true. You can set up triggers and other types of containers that execute actions when it's appropriate. And we'll get to that in much more detail. So here's just a picture of the NINA sequencer, and we're looking at a deep sky object instruction set, which is just a big container. And so at the top of that, over here, you can see, let me get my mouse over there. You can see where we've defined the target we're going after, M17, and the coordinates and the rotation that I want. And then it shows me a little horizon map here of where my target's going to be in relation to the horizon during the night. And then down here, we've got our instructions in various other components. Inside these containers, at least these 3 default NINA containers, you have loops, and a loop is kind of a sub-container that houses instructions we want to repeat over and over again. This should be a fairly familiar concept to anybody who's done astrophotography for very long. These loops can contain what are called triggers. Triggers are special instructions that only execute when the time is right, when something triggers them. So a meridian flip would be a trigger, and it gets triggered when it's time to do a meridian flip. Another trigger might be doing an autofocus after an HFR change of a certain amount. So there are various kinds of triggers that you can use. And then loops are controlled with loop conditions. So you can insert loop conditions, and there's a spot to do that. And the loop will continue to repeat as long as every one of those loop conditions is true. So we'll see an example of that here. We have a meridian flip trigger. It looks pretty simple. I just had dragged that over here from the right side. There's I would scroll this down. This is just a screenshot, so I can't do anything to it. But I would scroll this down and find the meridian flip and grab it and just drag it into the triggers area here. And now I'm going to do a meridian flip when my target hits this spot right here. And then here are some loop conditions. We want to loop while the target is above the horizon. And in this case, I'm just going to loop for 1 iteration. But I can take that out and just loop as long as the target is above the horizon. It's going to be well below the horizon by the time I get to 72 exposures of 5 minutes. If you look over here on this map, this target's going to be below the horizon before 1 a.m. So I'm not going to make it 6 hours of shooting before 1 a.m. So what'll happen is, when that target goes below the horizon, this loop will terminate automatically, because this loop while above altitude above horizon condition will no longer be true. So this just reiterates what I've been saying. The loop continues to iterate as long as all the loop conditions are true. One little minor point here, the documentation for NINA says that loop conditions are evaluated between instructions, but I haven't found that to always be true. I know when I'm shooting a 5-minute sub and the target goes below the horizon at minute 2 of that sub, it just immediately terminates. It stops shooting that sub and moves on. So their behaviors can be a little bit different than what you might find exactly in the documentation, but not substantively so. So this just, again, reiterates what I was talking about with loop conditions. Just shows you where they are. Then triggers we've talked about a little bit. The ones that I use are meridian flip, autofocus, and then we'll get to sequencer power-ups, which has some special triggers that are pretty cool. Again, the trigger condition is evaluated between instructions. So, you shoot a few subs, or you shoot a sub, and then Nina evaluates all the triggers. And then you shoot another sub, and Nina evaluates all the triggers and determines whether any action needs to be taken. And this just shows you where they are. So the sequencer is organized into 3 main areas. There's a start area, a target area, and an end area. And Ron Reacher is the one who told me about the sequencer sandwich. This is just an empty sequence. There's nothing in there, but you can see where it points out up here. Here's the start area where you can drag instructions in. And here's the target area where you can drag target instructions in, and then the end area. So what do we typically do with this stuff? So in the start area, we'll typically put in instructions that connect the equipment, cool the camera, wait until dark, and basically get ready to image. So here's a little example of that. These are just some instructions up in the sequence start area. Then in the target area, that's where the rubber meets the road. That's where you're going to put a deep sky object instruction set. That's a mouthful. But that defines your target, and that's where you're going to put instructions to actually shoot the target. That's where all the triggers and loop conditions and instructions for shooting will be. So that's in that middle area. And you can have multiple sequence targets in here. So when one finishes, it goes on to the next. Or even inside there, you can have multiple loops inside one target area where you could say, like, do moon dodging. I do this all the time where, like right now, I can shoot broadband early and narrowband late. So on one particular target, I might have a loop that shoots for a few hours broadband and then shoots for a few hours narrowband. So again, this is just a deep sky object instruction set inserted in the target area. And then you got the sequence end area, and that's where you can do all your cleanup, warm the camera, disconnect from everything, and then get finished with your sequence. And these are just some typical instructions you might find there. So what we've gone through kind of shows you the elements of a basic sequence in Nina, and it'll work, but there's some issues with it. So one issue would be, how do you wait for the target to get above the horizon if it's not above the horizon right at dark? What happens when the roof closes in the middle of the night? What happens when it closes and opens multiple times? What happens when clouds blow through and mess up your guiding and mess up some of your subs? One question I always ask is it really necessary to dither after every single frame? I probably should defer to Alex on that question. I don't. I usually dither every other frame or so. And then how do I know what's going on during the night? Is there any way I can find out other than, going to my laptop or going to my desktop computer and connecting to these remote telescopes and looking and seeing what's going on the remote computers? And then when I wake up in the morning, how do I know what's happened during the night, aside from going to the computer to take a deeper look? So that's where we kind of get to Sequencer Powerups. So this is a really well-designed, clever plugin for Nina, written by Marc Blank. Some of you may remember the text-based game Zork from the early 80s, and also Hitchhiker's Guide to the Galaxy. That was Marc that wrote that. And when I was talking to him about tonight, I asked him if there was anything he wanted me to say about him, and he said, do you want my shoe size and my favorite color? And I said, well, no. How about, are you a dog person or a cat person? And so I think we have the answer to that. He sent me that picture. But a super nice guy, and I've been working with him over the last several months, uncovering edge cases, badgering him for new features, and I think we've finally gotten it to where it works pretty well for me anyway. So hopefully it will work for other folks as well. So here's a link to the documentation, just marcblank.github.io. So what it does is it extends the advanced sequencer. It gives us the ability to declare constants, variables, and use expressions, and do some pretty interesting things with those. It gives us some enhanced instructions where we can actually put expressions in as the parameters. So rather than say just entering 24 for the number of exposures, I could put a variable there and set that variable at the top of the sequence and change that from night to night depending on what I want to do. It also collects information about what's going on with the imaging. So some of the extended or the enhanced instructions will determine what the FWHM and eccentricity are and other statistics are about the image that it just took. And Sequencer Powerups gives you access to that information. It also provides some custom triggers where you can create your own trigger and insert multiple instructions inside a trigger. So say an autofocus trigger, the default Nina autofocus trigger, you just drop that in and it just does an autofocus when the condition you've specified occurs. But with this, you can also trigger an autofocus, but then you can do other things inside the container of that trigger at the time the autofocus occurs. For me, the main thing is I want to get a message when an autofocus happens. And I also want to increment a counter because I'd like to see at the end of the night, how many times did my CDK autofocus during the night? Otherwise, I can't really tell. I can go dig up the Nina log or have Hocus Focus record a log and go dig through that. But just how can I tell at a glance what went on during the night? A similar thing with the Meridian Flip. Creates a container for the Meridian Flip where you can actually customize how it operates. And then there are a bunch of conditional containers, an if then else, loop while, and other containers. The only one I've really used is the if, but I'm sure more sophisticated people can find other uses for these things. And then one function I really like that it provides is send via ground station. So we'll get to this, but ground station is the plugin I use to send messages to my mobile devices. And with Sequencer Powerups, you can employ that, but you can also send the values of variables and constants and whatnot through those messages so that you can see things like how many autofocuses have I done, or how many iterations have I done of the target that I'm on right now? What was the full width half maximum of the last sub that I took, and so on. The big one though is when becomes unsafe. So this is a trigger that kicks in when the roof closes, and it doesn't just. There were functions in Nina to wait when an unsafe condition occurred, but that was really about all you could do, is just wait until it became safe again. You really couldn't it was, you could, but it was very difficult to take any concrete actions when the roof closed. So this really helps solve that problem. This is a trigger that kicks in when the roof closes, and you can put in whatever instructions you want into that container. And so typically I'll terminate guiding, park the scope, and close the cover. Pretty simple. And then just sit there and wait. Now this does adhere to the loop conditions and any other things that are otherwise going on in NINA. So if you're sitting in here waiting for the roof to reopen and the sun comes up, well, then the loop is going to terminate. Wind becomes unsafe is not going to make you sit there all day the next day before it terminates. So it does pay attention to loop conditions and behaves accordingly. So here's just a sample of usage of this trigger. It's pretty simple. You just drop it in with your triggers and put whatever actions you want in the container part of it. So when you see these little arrows, that indicates that you've got a container that you can open up or close. And then when the roof does reopen, the once safe container will execute. And then you can open the cover, slew back to your target, run an autofocus, start guiding, and start shooting again. As soon as once safe completes executing, it returns control back to the point in the sequencer where you left off. So if you were in the middle of shooting, say, 2 HA subs and you'd finished the first one and then the roof closed, as soon as the roof reopens, you'll restart that second sub in NINA. So it goes right back to where it was before the roof closed.
Does it check to see that the well, for instance, if it's closed for 3 hours and your target's gone, does it take care of that too?
Yes, your loop conditions will take care of that, because you're going to be one of your loop conditions will be loop while the target is above the horizon. And as soon as that target goes below the horizon, that terminates that loop, regardless of what wind becomes unsafe is doing.
Okay.
So that loop is terminated, wind becomes unsafe is terminated, and you move on to if you got another target, you move on to the next target.
Thank you.
Tim?
You bet. Yeah.
You mentioned when the target becomes up above the horizon, you must set minimum altitudes for your targets, right?
Yeah, you can do one thing I've seen people do. I don't do this. I may have it in some of these simple examples, but there's an offset parameter you can put in there. So you can say loop while target is above the horizon with an offset of 25 degrees. And so now your horizon is really at 25 degrees.
And are there any settings for the moon position?
Not that I know of. The setting I have for moon position is to get my iPad out and go to my app and find out where the moon is.
If you have a horizon, a custom horizon built into your program, does it take that into account? For instance, when it says get above the horizon, so it knows that, hey, there's a big tree there, so the horizon's at 40 degrees or something.
Yes, sir. It knows that.
So you could, if you wanted everything above 25 or 30 degrees, you could simply set your horizon at that.
You could set a custom horizon file with one entry in it, 30 degrees. And that's what I do.
And just to repeat, this is all for one single night. So you set these up for each night you want to run?
Well, I'll save this sequence, and then all I have to do is open it and click play the next night. If I'm doing the same thing night after night.
And there's a comment online that said, Lewis, yes, moon condition is available.
Where do you see that?
Okay.
It's somebody online.
Yeah.
Okay. Well, that you need to get that person on, because I want to find out about that.
Yeah, there's a here. I'm reopening it now. Yeah, it's part of the oh gosh, hang on. It's in my one it's in my sequence that's not with the scheduler. But yeah, there's a condition called moon angle, and it's in what category? It's in the loop condition category, called moon angle, and you can have, if you turn on the Lorentzian option, with like a width of 14 days, I think is the default. It will adjust. It's calculated it's like if the moon is smaller, it'll let you be closer to the moon, versus if the moon is more full, it'll enforce you being the full distance you want to be away, whether that's like 100 degrees for wideband or 40 degrees for narrowband.
Yeah, Molly, I think the moon is always the
Okay.
same size, isn't it?
You know what I mean.
Let's get along here. Let's
All
get
right.
along.
Okay, sorry, Tim, go on.
And actually, Eric, I think the moon is constantly gaining a little bit of mass as Steph hits it. So
Okay, you could be. Yeah, could
it's
be.
getting slightly bigger.
Shooting bits off into space too.
Yeah. So, yeah. So, sure. I guess you can. People who are more steeped in this than I am can speak to that. Then, as far as taking moon conditions into account, I'm sure there's all kinds of things you can do that I'm just doing by hand right now. Don't take all my enjoyment away from this hobby. So next step, we'll kind of look at a more intermediate use and talk a little bit about messaging. I use the ground station plugin. This plugin allows multiple ways to implement messaging, instant messaging, and so forth. The one I use is called Pushover. That does push messages to your mobile devices. It's a one-time $5 fee. You go on pushover.net, sign up, and you get an API key, and you can plug that into Nina, and then any pushover messages you send will go to your devices that you have registered with Pushover. You can play a sound on your device. I recommend you be really careful with that, because my wife was not happy when we were in the RV one night and my phone starts dinging at 4 a.m. So I've pretty much taken out all the sounds, but you can trap errors and get a message when there is an error. I do have a sound for that. So if autofocus fails or if something goes wrong, you can get an error message sent to your phone and have a special sound for that. And it'll tell you what the error is. You can use certain system values in your message. So, for example, the target name is one. That's really the main one that I use. And so down here at the bottom is just a little sample instruction. The title there, Mama Bozo. I named all my telescopes. I've got 3 of them out of Deep Sky West. They're called Baby Bozo, Mama Bozo, and Daddy Bozo, but based on how big they are. Then there's custom generic triggers. We talked a little bit about this. We talked about the DIY trigger a little bit. Normally, you could just drop an autofocus after HFR increase instruction directly in your triggers section, or you can use this DIY trigger thing. And then you can send yourself a message when an autofocus starts. I don't know who would want to do that other than me, maybe nobody, but I like to know when it happens. So I get a message on my phone when one of my scopes is doing an autofocus. So I just added these 3 instructions down here. One thing you do have to be mindful of, if you use a stock trigger as the impetus for your DIY trigger, you have to carry out the action that the trigger would normally carry out on its own. So I had to drop in an autofocus here. That's just one little caveat to be aware of. There's a custom Meridian flip trigger. Similarly, you can customize how it happens and what you want to do. A lot of the things that I wind up doing with it, I could do with Nina by default, except for like adding the messaging. So in the Meridian flip trigger, I send myself a message when it starts and then when it finishes. And this has come in fairly handy because I had an issue with one of the models on my GM 1000 mount, and Nina and the mount were not in agreement about when to do a Meridian flip. And so having this messaging helped me kind of work out what was going on there and fix the problem. So it does have some operational use from time to time. Sequencer Powerups also adds the capability to define and use variables in your sequence. And so some of you may ask, why would I want to do that? Well, I don't know. I'm sure people can figure out some way more advanced uses than I have, but one thing I like to do is count the number of autofocuses. So that's one place where I've used a variable. I've used them in several other places as well. We'll get to that hopefully if I don't run myself out of time here. So you need to define a variable somewhere in the instructions section, and then you can use it in your triggers or other containers in that that are contained within that context. So I'm here defining an autofocus count variable, and then when I do an autofocus, I just increment it by 1. There are also, this is one feature I begged Marc for that he added for me, was global variables. And we'll get to why I did that later, but mainly I wanted to have it in order to be able to fully automate taking calibration frames. It was very useful there. And then there are also these enhanced instructions that I've mentioned before where they can pick up or generate values that you might find useful either for reporting or for other purposes, like your last image's full width, half maximum, things like that. So here I've defined a global variable up in the sequence start area. I've just called it exposures per filter. And now when I go down in my target area and put in my exposure instructions, instead of putting 24 in here 3 times, I just put that variable in there. Then the next night I could change that to 22 or 26 or whatever I wanted to, and I wouldn't have to modify all 3 of these places. And finally, with this send via ground station instruction, you can send values through pushover, values that Sequencer Powerups has helped you calculate. So I've got my little focus count, and now I can use a send via ground station instruction. I drop a pushover instruction inside that, and then I can enclose autofocus count in curly braces, and I'll get a message that says, on the first time around, it'll say initiating autofocus 1 for M17. And then finally, we'll get to some more advanced usages here.
Tim,
Yes, sir.
I just noticed over on the chat that we have Marc with us.
Oh, hi, Marc.
Hi, Marc. Glad you're here.
Yeah, me too. Me too. Yeah, we've had a good time working on this. It's been fun.
Hey, Tim, remember before the show I said, don't screw this up? Really don't screw it up now. Marc's here. Okay.
Tim,
No,
we're not trying to make you nervous just because the author is watching.
I know, right?
I am. I'm trying to make him nervous.
It's working.
Okay, back to the show.
Okay. Any questions at this point?
No, I don't see any.
Okay. Very good. So either people completely understand what I'm saying or they just don't care. So one or the other. Okay. So in my own sequences, I use a little bit more of an advanced structure. I learned some of this from Ron, and I learned some of it the hard way. So I use a 3-tiered nested loop structure. And one of the things I do in my startup is set some global variables for later use. And then inside the sequence, I set up this 3-tiered structure, and it helps manage edge cases, multiple targets, and other various things that I want to be able to do in my sequence pretty easily and in a standard way, so I don't have to make a bunch of modifications when I go from target to target over time. I can just use the last sequence I was using and just change the target coordinates, and I'm good. So we'll take a look at this. This is a little chart I have that kind of shows this loop structure that I use. There's the main target loop. We've already seen one of those that establishes the coordinates and the rotation. And one thing we'll do there is wait until the target is above the horizon. This solves the problem that I mentioned earlier about what if the target isn't above the horizon yet when you start. If you don't have this safeguard in there and you just kick off your imaging loop and you have a wait until target is above horizon loop condition in there and the target's not yet above the horizon, the loop's going to fail and you're not going to do any imaging on that target because the target was below the horizon when you started. And so this is a way to avoid that in those cases where maybe the target isn't quite above the horizon when you start the evening. And then I have a loop inside that where I'm going to put all my triggers and loop conditions and initialization functions, unparking the scope, slewing to the target, and so on. And then there's the imaging loop itself that handles actually taking the exposures. So I'm going to go, if I can figure out how to do it. Yeah. I'm actually going to go to Nina and open up that advanced sequence. And I think Molly's going to post these sample sequences to the TIAC page somewhere. So
they're
if you
in the
want
video description is a link to where I stored them in our Google Drive.
Cool. So you can download these and look at them if you want to, and curse me later. So here in my sequence start area, I send myself a message saying that the sequence is starting, and then I park the scope. Usually it's already parked, but it doesn't hurt anything. If for example your scope does not power up and parked as in a parked state, then you can make sure it's parked then. Then I'm going to wait till around 8 o'clock. I guess I probably need to update that to 7:30 these days. Nights are getting a little longer. And I'm going to cool the camera and then wait for nautical dusk. I know a lot of people wait for astronomical dusk. I go ahead and get started at nautical dusk, and because it takes a little while to get slewed to the target and do your initial autofocus, and I might actually be able to cheat and get a couple of early subs that way. I don't know how other folks feel about that. One thing I kind of skipped over up here is I put in this container. It's an if test, and it's going to execute this container if the expression is true. Well, 1 is always true. So it will always execute this container. And what's in here is just me connecting to all my equipment. The connector does have connect all equipment, but I prefer to do this one at a time. That way I can kind of control the order that it connects in. And then if one of them fails, I know which one it is. Doesn't happen very often, but I did have a cable on my flat panel go bad on me about a month ago, and was able to identify it pretty quickly. Down here, I've got a bunch of variables that we'll get to later that help me take flats and darks and other calibration frames. So that's what all these variables I have defined are to help me take calibration frames at the end of the sequence. So we'll get to that, hopefully, if I don't run out of time. Let me know if I start running long on time. So in this case,
You're doing
Do what?
fine, Tim. You're doing fine,
Okay.
Tim.
Okay, good deal. So in this case, I'm going to shoot M17, and so I've dropped in a deep sky object instruction set container from Nino. You can grab it over here and drop it right in here if you want to. I've already done that, so I'm not going to do it again. And it has the coordinates, shows you my horizon line. That's my 30-degree horizon line, or maybe it's 25. And then shows you where the target is going to be, where it is right now. And then below that, I don't really have any triggers and just one loop condition. I'm just going to execute that outer loop one time. That's it. And then as far as instructions that I have in there, it just says I'm going to wait until the target is above horizon. And that's what this instruction does, is waits for that to happen. I've got a variable defined here. I'll explain that if I have time, but that prevents me from doubling up on slewing to the target and doing an extra autofocus if the roof happens to be closed when I start this sequence. So there are various edge cases like that. So this is the first inner loop that I'm calling the initialization loop. And this is where I've put all my triggers. So if something fails, I want to get a message to push over on my phone to let me know. If my target drifts because clouds move in front of the guide scope, or and my target drifts over time, I want to move back. It's typically not a problem with 10 micron mounts. I don't think I've ever seen this kick in before. Even when there's clouds and you can't get a guide star, it pretty much holds its position. Similarly, if for some reason guiding is interrupted because of clouds or whatever, this restore guiding trigger will cause guiding to resume. I think PhD is pretty good about hanging in there and waiting for a star to show up. So I don't know how much use this is. I don't know how often it kicks in. And then here's my when becomes unsafe trigger. And so when that happens, when the conditions become unsafe, I'm going to stop guiding, park the scope, and close the flat panel cover. Pretty simple. And then when conditions become safe again, I'm going to open the cover, unpark the scope, slew to the target, run autofocus, and start guiding again. Again, not anything you wouldn't really expect. And I have it wrapped in this if test. Again, if I have time, I'll explain why it's there. You don't absolutely have to have it. All it does is prevent me from, so I'll go ahead and explain it. If I start the sequence and the roof is already closed, when I start the sequence, then when becomes unsafe is going to kick in immediately. And I'm going to hang out and wait. And then let's say 30 minutes after the sequence starts, the roof opens. Well, then the once safe instructions are going to execute. And I'm going to open the cover, unpark the scope, slew to the target, run an autofocus, and start guiding. That sounds wonderful. But down here in my instructions, I'm already going to do that as part of my startup procedure. And Nina's going to pick up where it left off. Well, it hasn't executed any of these instructions yet because the roof was closed. So
Tim?
Yes, sir.
I don't see plate solving in here. Did I miss it?
Slew, center, and rotate does that.
Okay, thank you.
Yep. the slew center and rotate always does plate solving. And you set up your plate solving elsewhere in Nina. I use ASTAP, but I guess there's plate solve too, and there's other plate solvers you can use there. See, same thing here, Eric hit slew center and rotate. So, and it knows where to go because that's defined up here. So it knows what to plate solve to because of that. Okay. So that kind of explains the when becomes unsafe trigger, and that's the operational code that I use for this. And then I do have a DIY trigger for autofocus, just to send me a message when that happens. And then I do my own meridian flip, and you can set the default meridian flip not to focus, but I took the autofocus out of this. I don't focus after a meridian flip. I just count on the HFR change to tell me when I need to focus. I know there are people who get ultra precise about that, and maybe someday when I have more experience and know more about what I'm doing, I'll do that. And so finally, again, this loop is going to execute one time. And so when if the roof's open and it starts, this loop is going to execute one time. It's going to open the cover, unpark the scope, slew, focus, start guiding, set a few variable values. And maybe if I want to shoot stars for a narrowband project, I may just go ahead and put some smart exposures in here and just shoot 20, 60-second subs for those. But then I finally get to my imaging loop. And what happens here, screen real estate is tough. I try to kind of move that out of the way. So here in my imaging loop, I'm going to loop either until the target drops below the horizon or until dawn, whichever comes first. Remember, if any one of these loop conditions goes false, the loop terminates. So inside that loop, I'm going to take 2 HA subs, I'm going to take 2 O3 subs, I'm going to take 2 S2 subs, 5-minute subs, and then I'm going to dither. And I'm going to repeat that over and over and over again for as long as I can until the target drops below the horizon or until dawn comes. And then I've got a message over here. I wish you could see all of it, but at the end of every iteration, I count the number of iterations and I send myself a message on my phone that tells me which iteration I'm on, for which target. You can barely see that. And it tells me the full width half maximum of the last sub I took and the eccentricity of the last sub I took. So I can just take a quick look at those values and say, yeah, that looks right. Or, oh, I don't want to see an eccentricity of 4.6. So there you have it. And then once this target drops below the horizon, you can see the triple loop structure here. So this was the outer loop. All it did was wait until the target climbed over the horizon. Then all this one did was all the initialization code, opening the cover, slewing to the target, initial autofocus, and so forth. And then this is the imaging loop where I go round and round and shoot all my subs. And once that target goes below the horizon, it falls through to here, and I'll start my second target. So this basically is the same, except I did make a little change down here in the imaging loop. I have 2 imaging loops. And the first one, I'm just going to shoot broadband until 1 a.m., till the moon starts to rise. And then I have another imaging loop where I'll shoot narrowband until dawn. Other than that, it's very much like the first target. Finally, I get to the end here, and this is my end sequence area. I'll stop guiding. I'll actually close PhD2, park the scope, close the cover. And now here's where some of these variables that I had defined way up at the top of the sequence start to kick in. So here I'm going to decide whether I'm going to take flats or not for my first target. And there's this variable take flats target 1, and there's this variable rotation angle target 1. So where did those come from? So scroll back up. Got to go a little ways here. I may collapse this target to get it out of the way. And in my initialization code, after I slewed, centered, and rotated, I set this variable rotation angle target 1 to the rotator position. So this gives me the mechanical rotator position, not the sky position, but the mechanical rotator position. And so I've stored that now in this variable after I've slewed to it. So I'll know what my mechanical rotator position is for target 1. I go back up a little further.
Tim, can we interrupt for a
Yes,
second?
sir.
Jaime or Terry, we need you to look into the Google Meets part and admit somebody who's waiting to get into the room. Thank you, Tim. Thank you. That's over. Thanks, bye.
Okay. So I came back up to the top to my start area, and I see take flats target 1. I have it set to 0, but if I want to take flats, I'll just change that to 1. And so at the end of the night, it'll come down here. I've stored my rotation angle, and so my rotation angle is going to be less than 990 degrees. Let's hope. And I will execute this code. I'm going to send myself a message saying I'm taking flats. I'm going to take this many exposures. And then I'm going to execute this instruction that rotates the rotator to the first target angle. So now I have not traditionally been this anal about my flats. I take flats about once every 6 months, and I don't care what the angle is. But I've been told that I could make some incremental improvements if I was a little more careful with my flats. So this is part of it. And so this allows me to take flats at the exact angle that I shot target 1 at. So I rotate to that angle and then take a bunch of trained flat exposures for each filter. And similarly, I've got the same thing for my second target. This is kind of a brute force way to program it. You know, if this was a full programming language, I'd have an array and I'd do all kinds of, I'd do some for loops and things like that, but it's not a programming language. So I have a variable called take flats target 2 and rotation angle target 2. And basically the same thing, just taking flats for target 2. But so if I needed flats for, if I needed new flats and I had 2 different rotation angles during the night, I could get 2 different sets of flats, one taken at each rotation angle. And then the following ones are much simpler. Taking flat darks, pretty simple there. Just a single trained dark exposure. I always take my flats at the same exposure time, so I only need 1 set of flat darks. I just vary the light panel to account for that. And then I can take bias frames. That's fairly simple. Just 1 smart exposure instruction. And darks as well. An exposure instruction for each of the different exposure times I use. The only exposure times I really use are very rarely 30 seconds and then 60 seconds for stars, 180 seconds for broadband, and 300 seconds for narrowband. And then that's it. This next slide just kind of shows that structure where with 2 targets and with a loop for broadband and a loop for narrowband. So I just wanted to have that in here if possible. So I've already kind of been through this. Use variables to control how I take calibration frames. The main one is the rotation angle. That was the key. That was why I asked Marc for global variables, so I could record those rotation angles and use them at the end of the night. Because I'm not sure, but I didn't think people would really appreciate me turning on my flat panel at 2 in the morning in the middle of the observatory. So I wanted to avoid that. And then we talked about one edge case. There are other little edge cases where mainly when things happen and you're doing your initial slew and autofocus and whatnot, these things take time. Opening the cover, these things take time. So I have seen the roof open and close and open and close, while I'm trying to get all that stuff done. And so that can create some edge cases. The worst thing that's ever happened as a result of one of those edge cases is I wound up running 2 autofocuses in a row. Oh well, not a big deal. Otherwise, when becomes unsafe and once safe, really handle these situations extremely well. So that's pretty much all I have. I think I landed on time, or at least on airline time, I landed on time. I'm 1 minute and 24 seconds late, I guess. So I'll throw it back over to you, Molly and Eric and others.
All right. Yeah, we've been trying to get Marc in the room, but we're having some trouble getting to the page where we can admit him from inside of our streaming software. So
gosh.
I know how to do it, but if I do it, I'm afraid I'm going to kill the stream by kicking one of them out by accident. So, but we'll see what we can try here. Yeah, let's. I was looking at the chat to see if we have any other questions. Yeah, guys, if you have questions you want to ask, now's the time to do it before we get to the end of tonight's show. Does anybody in the room here have questions?
Tim, do you have a countdown for a sequence, or do you just go by time?
I just go by time. I actually kick them off any time during the day, and it waits nowadays till 7:30 or 8 o'clock, and then one of those first instructions is just wait till 7:30 or 8, and then it takes off and starts cooling the camera and getting ready to go.
No, I mean by the number of subs that you want for each filter. Is that part of the sequence?
Not explicitly. I mean, there are all kinds of ways to do that. The way I do it is not necessarily the way other people do it, or the way you should do it, or the way you can do it. I try to fill every available minute, and I just loop while the target's available and take as many subs as I can. Do I have a target in my mind of what I want to reach for a particular target? Sure.
Let me see if I can restate that. First off, if you're just going to be visiting with us and not using your presentation anymore, you can stop sharing your screen and you'll just come out full size.
Okay.
I think the answer that you just said was, I tell it to take pictures of X minute exposures for an hour and a half, and it takes as many as it can get. Whereas many of us say, I want 20 exposures of 5 minutes each, or whatever. So you just tell it, I want an hour and a half's worth, as many as you can get in that hour and a half, or whatever, right?
Yeah, keep shooting until it goes below the horizon, and I'm going to shoot 2HA, 203, 2S2.
Okay.
And I'm going to cycle through that and get as many of those 3 different.
Have you thought about, just to change the subject of the question, have you thought about what it would take to, so that you wouldn't have to do this every day, that you could just load in a month's worth of what you want to do at any given time and see how it goes? Would
Oh, you mean a
NINA-
scheduler?
Yeah,
You
that,
mean
well, not
a
necessarily.
scheduler like
You can use, you can
NINA
use,
itself.
you can
Like
use like
ACP or something?
a lot of, there's conditions, like using these conditions, like for like moon angle, for example. I have a sequence that has both broadband target or wideband targets and narrowband targets. And if it skips a wideband target because of the moon angle, it will go to the narrowband target instead. So it's kind of a way to have it run semi-automatedly for a short period of time, like a month or so, without having to actually use a target scheduler.
I think something like ACP, you can actually just create a bucket.
Well, so that's what
target.
the target scheduler does, is it runs like ACP, but as a step, as a bridge between that, before going full scheduler, you can use a lot of these conditions in your sequence to have it decide whether it's going to shoot a given target at all. And if not, go to the next target because the moon's too bright or what it hasn't risen yet or whatever other condition.
And
Yeah,
even with
you
a
know-
scheduler, you are still going to go back and evaluate the subs that you're running because, you know,
Yep.
there are some good subs and bad subs, and you may want to go in there and change things. So I don't think you can let this thing run autonomously for very long without really evaluating your data and see how much more you need to get to your endpoint.
Yeah, and so one of the things that this is kind of where I am in the process, and I'll probably move past this at some point, but yeah, I look at my data every morning, and sometimes I change my mind on a whim during the day, or even, you know, right at game time, I may change my mind about what it is I want to do. Like, you know, I had planned. I've been shooting M17, and I had planned to get a bunch of data on that. It's kind of going away now. And this morning I processed the narrowband data I had, and I thought it was okay. I didn't think I was going to get enough time with it to really improve on it. So I'm just going to go to another target. There's just not enough time left with M17 to get it done. So
We've
the
got
way I would like to.
We've got a question coming in from Jeff Marks. What timing? He says, with 2 exclamation points. I've been working on building sequences using the software from my remote observatory. Where can I get templates and examples?
In the doobly-doo.
I put links in the video description for the for some sample sequences that Tim sent me.
Okay, so there's a link in the program description.
Yeah, so it takes you to a folder I created in our Google Drive. So they're hosted there, and you can go download. There should be 4 JSON files listed there that Tim sent me.
Okay.
Very cool.
And as you noted, we mentioned John Hayes earlier, and he talked about how he set up some remote stuff down in Chile, I think. And we put the links in the chat here, so to John's work. So.
Yeah, and it's really an excellent guide on how to build out and how to design and build out and place a remote telescope, and all the things you might think about, and some of the things you don't think about when you're doing that you need to think about. Really fine work from John on that.
Mhm.
So I could, if I can let Marc into the room if he's still in the waiting room. But it might kick out Terry or Jaime. So I could try this with the knowing that we could
So
accidentally.
just in case, maybe. Goodbye, everybody.
No. Let's not do that.
All right.
No, we don't want to have the end of the unexpected end of the show.
We don't have any more questions in the list.
Yeah, I don't see any more.
So we can let him in after this show.
So we might destroy the YouTube part of this, but we can still be.
Well, this could be
See,
a good test.
guys, that's
See-
the cool part
No,
about
no.
that's the cool part about putting on a presentation. You get to come in here and hang around with us for 20 minutes while we're making sure you know what you're doing, and then afterwards you can hang around for I don't know how long they hang around with. I can't handle as long as those guys can hang around. But we can discuss how the program went and all the other things we're doing in astroimaging and stuff like that. And by the way, you don't have to be completely knowledgeable about everything that there is in astroimaging. You don't have to be some kind of an expert to be a presenter. What you have to do is be able to explain something that you found is useful. Now, you say, hey, other people already know about all this. Maybe, maybe not. Maybe you can be part of a beginner's program instead of an advanced program. But we need all kinds of presenters. So please send us, contact us at the on the website. There's a place to contact us. We need presenters, guys. Okay, I'm over it.
So it occurs to me that neither one of the admin accounts are logged into tonight's stream. So I think if I log into the admin account, it's not going to kill the stream because I think you guys are using your personal accounts. Is that right?
Yeah.
Okay.
Go ahead.
That didn't occur to me until just now. So let me try this here. All right, sign in.
Mark, if you're listening, we're going to try to get you in.
Yeah, you may need to try to enter the room again so that it kind of refreshes it.
And if the rest of you disappear, bye-bye.
There's actually quite a
I don't think it'll kill it in this instance. Give me 1 second to log into the account here.
There's a long delay for the stream going out.
See, I told you didn't have to know everything about everything to be on the astroimaging channel.
All right, I will lurk in the room and see. Let me get in here just a second. Join.
Don't screw it up.
Admit. There he is. All right, now I can grab him.
All right.
Hey, Ben Grampy, how you doing?
You
got
are
a
muted.
microphone?
So unmute and turn on your camera so we can see you.
Maybe not. Maybe you can be part of a beginner's program instead of an advanced
Oh,
program.
Now we're hearing
oh.
in the background. You're on the mute that
On the website.
I would mute YouTube and turn on your camera, Mark.
It occurs to me that neither one of the admin accounts
Turn
are
your
logged in.
speakers off or something. I don't know.
I think if I log into the admin account, I'm going to mute him for a second while he gets that figured out.
Okay. Well,
Okay, go ahead. That didn't occur to me until just now. Now I just get to hear myself talking.
Molly, you're running the show.
All right. Well, in this instance, Mark, why don't you hang out and we'll chit chat. We'll go ahead and end the show tonight, and Mark, we can chit chat. We'll yeah. All right. Anything else to say before we go?
Yes. Goodbye.
All right. Have a good night, everybody.
Thank you. Thanks for having me.
Have a good night.
You can stay with us if you want, Tim.
Yeah.
Okay.